drive belts, which will eventually be upgraded to full-on timing belts. On a 2-to-1 ratio from the motors to the tower, this point has a serious speed.
Our vehicle is powered by 4 9-volt batteries to run our 2 18-volt motors. They run 2 motors that are 60 inches each. Our steering is a skid steer model that allows us to have a 0 turn ability. Based off our Define project, we found that the kinematic diagram on SolidWorks showed that the steering wouldn't be tight like we wanted. Did it on a pulley system that's a 2-to-1 ratio from the motor to the wheels, axles.
Okay, so this is the swamp section, and I've created a float switch here in the water. You can see as the water level will come up to the correct level, it will activate this float switch by making a disconnection in the wiring when it floats upwards. This will send a signal through the wiring up into this Arduino board. This Arduino board will then be connected to the pump switch later on. Here's a general overview. You can see that the float switch is in the activated position, which will send a signal to turn the pump on. Here from this wiring is where you can see connected to the pump, which will then pump the water out to be able to maintain the steady state. And over here we have the head loss section, where we have 2 mesh fitting hose ends and then beads inside to make sure 2 gallons per minute is attained.
Currently, Teammate is a bunch of autonomous workers who have devoted over 95 hours to this project, and we have currently spent $205 of our $250 budget. Currently, my integer programming code only takes into consideration the difficult levels with each element, rank, and difficulty. So, unfortunately, I was unable to obtain real-time data, but once I will take in consideration vehicle constraints so that I can then update my integer programming model, which will give me approximately 8 elements that I should consider pursuing with more additional real-time data, which will be used through dynamic programming to obtain the optimal path. To be or not to be? That is the industrial engineer's question.
Okay, go.
Our vehicle is powered by 18-volt.
Okay, wait, this way was the loose way, right?
Yeah, counterclockwise.
Okay, yeah, that